क्या हुआ?
Please, sir.
Yeah, good afternoon, sir.
Yeah, good afternoon, sir. Very good afternoon, sir.
Yeah. Thank you, sir. I hope I am audible, right? And shall we wait?
Yeah, audible, sir. Perfectly all right, sir.
Okay.
So shall we start, sir?
Yeah. I think I'm okay.
Okay.
Very good afternoon, all of you. Those who have joined us online as well as offline. And you all know that today we are going to have 8th lecture in the series of our monthly scientific interactive series. And today's presentation is of great importance for us as well as for all the environmentalists who are working, especially in the Indo-Gangetic plain. It is about air pollution sources, characteristics, and issues associated with air management in India. And our resource person for this very important lecture is Dr. Kripa Ram from Institute of Environment and Sustainable Development, Banaras Hindu University, Varanasi. Dr. Ram is closely associated with Bihar State Pollution Control Board, and on earlier occasions also we had the privilege of having his important suggestions and all. So it is a privilege, sir, to have you for this lecture today. And to start with, I would like to request Member Secretary of this board, Sri S. Chandrasekhar ji, to have his address, sir. Welcome address.
Thank you so much, Dr. Naveen Kumar. So in the outset, I welcome our today's honorable speaker, Dr. Kripa Ram, Assistant Professor from Institute of Environment and Sustainable Development, Banaras Hindu University, Varanasi. Sir, welcome. Sir, I welcome you on this occasion, sir.
Thank you so much, sir. Thank you.
It's our privilege, and we are extremely happy to have you today to listen to your speech, sir. This is part of our monthly scientific interactive series, and this is the 8th such lecture series which you are going to address us today. So, and today's topic is that air pollution sources, characteristics, and issues associated with their management in India. This topic is so relevant to Bihar that Bihar is one such state located in the Indo-Gangetic plains that the particulate matter pollution, aerosol pollution, is so pronounced, and which is also affecting the common public, the health of the people here. This has also been discussed by various organizations, including MOFCC and CPCB. We are in touch with Dr. Kripa Ram ji for quite some time now, and BSPCB is going to sign an MOU with Banaras Hindu University, Institute of Environment and Sustainable Development, soon for studying source apportionment, carrying capacity, and preparing emission inventory. Sir, already we have started with the work, initial work. I think we have collected some sample few days back.
Right, sir.
Sir, this is part of the monthly scientific interactive series. The main objective of this series is to take the latest happenings in the field of environment, especially those issues which impact the state of Bihar most, among the students, among the faculties, teachers, among the common public. So that's the reason why we are live streaming this lecture every month, and this has been continuously been done, sir. And today we are extremely elated to have you among us. And also I take this opportunity to welcome those who have joined us today virtually as well. I'm seeing a lot of people have joined there. Also, I welcome my colleagues who have joined physically over here from my pollution control board. So with this, sir, I now request our board analyst, Mr. Arun Kumar, to introduce our resource person. Please, over to Dr. Mr. Arun Kumar, please.
Thank you, sir. Good afternoon to all. It's my privilege to say something about Dr. Kriparam. Dr. Kriparam is working as an assistant professor at Institute of Environment and Sustainable Development, Banaras University, Varanasi. He completed his postdoctoral study from the University of Tokyo, Japan. Prior to joining Banaras University, he has served as scientist at National Environmental Engineering Research Institute, NERI, and Inspire Faculty, IIT Bhubaneswar. Dr. Kriparam has obtained his doctorate degree in atmospheric chemistry from Physical Research Laboratory, a premier research institute under the flagship of Department of Space, Ahmedabad, under the supervision of Professor M. Sari. Dr. is associated with research on atmospheric chemistry. His research interests include carbonaceous aerosol with emphasis on black carbon, secondary aerosol, optical and microphysical properties of aerosol, aerosol cloud interaction and climate, trace gases and ozone measurement, stratosphere, troposphere exchange, volatile organic compounds, polyaromatic hydrocarbons, and platinum group elements, carbon dioxide capture and sequestration. Dr. Ram has authored and co-authored 70 plus peer-reviewed scientific papers and presented work at many national and international conferences. His papers have been widely cited, and the author has a total citation of 3,050 with H index of 30 and I-10 index of 49. Dr. Kriparam has Dr. Kriparam's contribution have acclimated recognition from honorable subject experts around the world, and his academic career is decorated with several reputed awards and fundings. Some of scientific recognition includes Inspire Faculty Award from DST, President's International Fellowship Initiative Award for Visiting Scientists, Chinese Academy of Science, China, Connect Fellowship of Alexander van Humboldt Foundation, Berlin, Germany, Early Career Research Award 2016, Science and Engineering Research Board, Government of India. So I congratulate him for obtaining such awards. Thank you.
Good afternoon, everyone. And yes, sir.
ठीक है sir.
Okay. And Honorable Member Secretary, sir, Arun sir, Naveen sir, and Saha sir, colleagues and friends who have joined online for this meeting. I would really first like to congratulate BSPCB for such a nice start. Actually, I feel this is very important in today's scenario, that there should be a lectures from eminent scientists and who should be discussing about the say right from the basics of the air pollution, their characteristics and issues that are there. Actually, this is really very wonderful kind of initiative that is taken by BSPCB. So I must congratulate you all, sir, for this one. And today's topic is actually very relevant, given that almost entire country is affected by the air pollution sources, whether it is particulate matter pollution or gaseous pollutions. You talk about anywhere, any city, none of the cities of India has actually the guidelines that is prescribed by the WHO, and some of the cities do have follow the guidelines, or they have under the threshold limit as defined by CPCB, but most of them are not. And as of now, in India, we have almost like 77 non-attainment cities or so. So this is really a very important issue, And I am very happy to be part of Bihar Pollution Control Board, and as an expert or kind of colleagues working together to solve this one of the issues that is very challenging issues that we are all facing. So thank you, Naveen ji, for an excellent introduction, and Arun sir and then member secretary sir for inviting me today. So I'll start with the presentation now. This is very fundamental question that I ask myself, and whenever I take lectures, I start with this one: that what do we a planet need to have if it has to have a sustainable life, or it has to have a life actually? So if you talk about these things, these are the 5 elements actually: sunlight, water, food, temperature, and air. These are the 5 basic ingredients that any of the planet must have in order to have a life on that. So if any of the 5 things are not there, life cannot sustain there. Okay. And now the next question is not only that their presence is important, but they have to be present in a very appropriate amount. If something is present in a very high quantity, it cannot be actually sustainable. For example, if you look at the our solar system, the planets that are closer to the sun, for example, Mercury, Mars, and then Venus, you have a temperature very high there. I'm not going to give lectures on that one. So that because of the temperature, life cannot sustain there, right? And this is the, so where is, which one unique planet is having all those things? So if you see this one Earth, it is very unique and habitable planet because of the following reasons. It is situated about 1 astronomical unit distance from the sun. 1 astronomical unit is about 1.5 into 10 to the power 8 kilometers. And then global average temperature is about 15 degrees centigrades. So, our human body temperature is somewhere around, 36, 37, 38, whatever you can call it. And then based on that, if you just see that the global average temperature, if it is low, much lower, the life again, but it cannot be sustainable there. And if the temperature is more than say 40, 50, right now we are actually approaching summer, and the temperature will go say around 45 plus or so. So again, it will be very difficult. In a colder region, it is also not very sustainable. But this is very important thing that, Earth has such a unique, and I will discuss that why it has so, what are the reasons for this unique ness of these planets that is have actually. So this is actually the presence of the atmosphere, composition, and amount. So I talked about that, if you look at the atmosphere and its composition, they are actually in very appropriate amount. You have major gases and trace gases, which are very important for scattering processes and absorption process. So they either scatter the solar radiation or absorb the harmful radiation before they reaches to us. Water and soil is of course very important. We need actually water, carbon dioxide needed for the photosynthesis. Soil is needed for the food production, and water is needed for the food production. And there are many more. So I just pose a question: that have we ever thought that our atmospheric structure, ocean, forest, and polar regions, they are present at a very specific locations? And if you just look at this and see that why they are present at that appropriate locations, it itself gives a kind of feeling that the nature has created such a nice environment for us, that we are actually having and feeling this kind of unique habitable environment. So actually we must thank the nature for its creativity. I'm not talking about the religious things, but if you just talk about the nature has almost everything in a very perfect place and very perfect amount. Now, the next question is, since the topic of the discussion is today is about the air pollution, so, and I would be specifically focusing on the particulate matter because of the limited time. So particulate matter pollution, we focus because of the public health. We talk about the chemistry that is happening in the atmosphere, the visibility. Indo-Gangetic Plain and the northern India experiences a huge reduction in visibility in the winter time, and then trains are cancelled, flights are delayed, and then lots of economical damages happens because of this low visibility or poor visibility. But not only that, these aerosols are somehow very important as well for us, because if you just assume that there was no aerosols or particulate matters, there could not be any cloud formation. So in order to form cloud, we need actually aerosol particles. Those aerosol particles are called cloud condensation nuclei, on which the water droplets actually accumulate, and then the through the condensation processes and other physical processes, this leads to a bigger size. Not only that, if you talk about the ocean, you see our ocean has huge productivity, lots of microorganisms. It is home for lots of microorganisms in that, and these microorganisms need kind of nutrients. For example, we need food or nutrients to sustain there. Similarly, the microorganisms that are there in the ocean, they also need. So there are two ways that they can get the nutrient. One is through the riverine input, and then other one is the aerosol. So if the air pollution or particulate matter deposition play a very important role in the ocean fertilization itself. If we talk about the climate forcing, of course, there are good and bad things about this one. Some of the aerosols are actually causing cooling, for example, sulfate, nitrate, and organic carbon. But some of the particulate matters like black carbon and brown carbon, they are actually forcing, positive forcing. So they lead to increase in the temperature of the troposphere. So when we talk about particulate matters presence is very important. So as if I put the things in a very simple way, that if the particulate matters were not there, the life actually could not have been that very easy. But now the question is that we all know, if something, the presence is important, but if it is present in a less quantity, then it is also not good, and if it is present in a high quantity, then it is also not good. And in order to define that how much it is good or bad, we have agencies like Central Pollution Control Board and State Pollution Control Board in India, which decide that what should be threshold level of the particulate matter. So now the point is that if the aerosol pollution is high, it is certainly going to affect the public health and visibility. If I talk about these things, these two are one of the very important and pertinent issues that we are discussing or we are facing today. So if you see that there are many organs or human bodies functions that can be hampered just because of the, if you inhale more of particulate matter. So when we inhale actually air, we don't just inhale the air composition that is there, oxygen, nitrogen, and argon, but at the same time, we also inhale particulate matter together with this. And if the particulate matter is present in higher quantity, and if it is, we are inhaling that one, so you can have a very respiratory diseases, you can have cardiovascular damages, fatigue, headache, and anxiety. You can have irritation of eyes, nose, and throats. I think everybody must have experienced that if you are traveling, and some vehicle is there which is giving lots of smokes, and you are traveling behind, it is actually going to irritate your eyes and nose and then throats. You are going to cause throat infections also. So this is really very important that pollutants are but one thing is that some individuals are much more sensitive to pollutants than others, and this is the reason why India or CPCB have relatively higher PM levels, threshold levels, compared to WHO or developed countries. Because developed countries, people living there, they are not exposed to that kind of particulate matter concentrations. But of course, even our CPCB guidelines or whatever the guidelines we have, they are still very high. So children's, infants, and older people are highly vulnerable to the kind of this disease that can be caused by the air pollution. So this is very important that we must understand. We must try to keep the minimum level of a particulate matter, which does not hamper our health or other things as well. So now the next question is that, okay, what is the particulate matter? So the particulate matter is also called as atmospheric aerosols. And when we say aerosols, it is kind of made of two words, air plus sol. So air is actually like, what we call air as a medium here, and sol means solid particles. So anything that is suspended in the atmosphere is actually can be called an aerosol. But we have a definition for PM 2.5 and PM 10, because in principle we have a particulate matter of 100 micron or so, but those aerosols are, because of the gravity of the sun, they are deposited on the earth's surface. But in contrast, these particulate matters PM 2.5, which means that we talk about the aerosols and take their aerodynamic diameters, if they are less than 2.5 micron, they are actually the aerosol that are less than 2.5 micron are called PM2.5. So now the next question that comes to our mind that, okay, we have aerosols in the atmosphere. So what is that typical composition? So I give a very typical composition here that it can have a mineral dust. You have carbonaceous aerosols in that. You have sea salt if you are very close to the ocean. You have nitrate, sulfate, and ammonium. These are also called as anthropogenic ionic species or secondary inorganic species that are there. And this is very prevalent in the urban atmosphere. You have volcanic aerosols that also emit lots of SO2 and ice. We don't have volcanic aerosols, so it is actually happens very in a sporadic time or very occasionally. But the volcanic aerosols, this is also very important. These SO2 is when they are impacted. And if you just talk about the 1991 Mount Pinatubo volcanic eruption that happens in 1991, it released so much of sulfur dioxide and ash in the atmosphere that there was a global cooling. I'm talking about the global cooling, not on the regional scale. The entire globe was cooled by a temperature of 0.5 degrees centigrade. So sometimes volcanic eruptions are very important. And here also you can just imagine why volcanic aerosols are there. So it means that Earth is actually trying to accommodate itself actually. Okay, the temperature becomes very high, its living habitants survival becomes very difficult. So in that way, Earth also tries to do that one. I'll give you an analogy here. So for example, if you have somebody has a fever, okay, what will happen? Initially, all the antibodies that are there in your body, they will try to fight with that, whether it is bacterial or viral fever. So they will start fighting. But what will happen at the end of the day? What will happen if your immunity is weak, and if your immune cells are weak and they are not able to produce that amount of antibodies, the temperature will keep on rising. So when the temperature is keep on rising, there is no control. So you have to take tablets or paracetamol or something like that. Okay. So similarly, it happens. Earth is actually an ecosystem which tries to balance everything, and it has its own mechanism. And we must, again, I must appreciate, and I must say that the environment or the kind of nature has created, it's really very important. Okay, so let's not go in that details. So I will be focusing on two things, because mineral dust, sea salt, and volcanic aerosols, these are also called as natural aerosols because they are not generated by man-made. But if you talk in the mineral aerosols, there are a small component of, like, you have kind of agriculture activities and other things, and construction activities, then that can be anthropogenic as well. But here is another component. The most important component is carbonaceous aerosols. I said that, okay, sea salt is relevant only in the coastal areas. Volcanic aerosols and SO2 and ashes, they are not there actually all the time. So you basically are left with three kind of aerosols: mineral dust, carbonaceous aerosols, and then you have anthropogenic ionic species. So this carbonaceous aerosols, again, I will talk separately about the mineral dust if the time permits, or in some separate lectures, because this is again a very kind of devastation, kind of presentation is needed. So I will be mostly focusing on the carbonaceous aerosols today. So carbonaceous aerosols has two components. What is called primary organic aerosols, and then primary organic aerosols means that aerosols that are generated directly by the emission. You have by the, for example, vehicular emission or industrial emission or biomass burning activities. So that is anything that is coming in the particulate form because of the kind of burning or kind of activities, that is called primary organic aerosols. And in this one, actually, you can have two components. You can, if you just talk about this primary aerosols, don't talk about the primary organic aerosols. So it has two components. One is organic carbon and one is elemental and black carbon. So you can also realize here that both are coming from the same sources and same processes they are coming, but organic carbon is mainly scattering. So this means it is very good for us given the scenario that Earth's temperature is increasing. So if the organic carbon concentration increases, there is expected to be cooling. But the bad point is that when this organic carbon is emitted in the atmosphere, elemental or black carbon is also simultaneously emitted, right? So it's simultaneously emitted and it is actually absorbing in nature. But the good point is, so if it is absorbing, this means that it is going to increase the temperature of the troposphere. But the good point is that in contrast to organic carbon, which can be about 10 to 30% of the mass, our elemental or black carbon is only 2 to 10%. So this is really very important for a country like India, where we have lots of emissions. I will discuss about this, that how these ratios are very important for us. Then another very important component that has been coming in recently is secondary organic aerosols. So secondary organic aerosols is basically produced by the precursor gases, and then through the reaction I will discuss in the later sector. And this is actually mostly in the soluble form. So it can be about 30 to 60% of OC. This means, if you just talk about that, this means about 10 to 18% of the organic carbon that is emitted, it can be actually secondary organic aerosol itself. And this is very important because these aerosols are water soluble. So this means they are water loving. So water molecule can condense again on the surface. So these are very good source for cloud condensation nuclei. So this paper were published earlier in 1991 in Nature or so. There's lots of papers on this one. And then there are lots of characterization techniques, but for the sake of the complexity, I am not going to discuss those characterization techniques, like how you characterize this one. But I would just say that characterizing primary organic aerosols is relatively easier compared to secondary organic aerosols, just because secondary organic aerosols has lots of precursors, and all the precursors cannot be modeled. Here, if you can see here, that primary emissions, like it is whether it is biomass burning emission or fossil fuel, these are producing primary organic aerosols. You can characterize by measuring the organic carbon, elemental carbon, and potassium. Potassium is a very good tracer for biomass burning. So if you measure in during the burning period where the biomass burning takes place, the potassium can be very high. So then we can say that, okay, it is probably there is lots of biomass burning emission. But then we also normalize with the either with the EC concentration or OC concentration to see that how much biomass burning components are there. There are better markers now available, like isotope markers like carbon 14, and this paper was published actually using the carbon 14, and was published in Science in 2009. So this is very recent developments on this one. I was talking about the secondary organic aerosols. As I said, that there are lots of volatile organic compounds. They are emitted together when the particulate matter is emitted actually. And then you have lots of oxidizing species in the atmosphere, OH, ozone, and NOx. And then through this one, they produce oxygenated hydrocarbon. So now imagine a situation. I mean, you can just think of, if there was no ozone, or there was no OH radical, or NOx was not there in the atmosphere, the concentration of volatile organic carbon would have been increasing, right? So this actually, this presence of ozone, tropospheric ozone, is also very important, right? Otherwise, this atmospheric chemistry cannot happen. Then you have biogenic and anthropogenic secondary organic aerosols. Biogenic means from the biological activities. And then there are WSOC to OC ratios, which are usually used for the quantitative information about SOA. I talked about this one, carbonaceous aerosols in that atmosphere, troposphere, why they are important. So you can see here, they are very important for the studying the cloud condensation nuclei and droplet formation, which subsequently are ultimately leads to the formation of the rain or rain formation. And then lots of volatile organic compounds are emitted. They are actually converted into the particulate form. So once they are converted in the particulate form, they are either deposited or they are actually attached to the surface of the pre-existing aerosols, and then they become they're deposited on the Earth's surface. So the presence of, and then of course, because of this one, you can have a direct aerosol effects like scattering and absorption. So it leads to the change in the Earth's temperature. I'm not going to talk about much in this one because of, again, limited time. But at the same time, indirect effect is also there, which we really don't see. If there are lots of number of aerosols, so what will happen? For the given amount of water that is available for the cloud formation, there are number of aerosol particles, or CCN particles are higher. So per CCN, the water availability will be low. So this means the droplet size will be smaller. And when the droplet size will be smaller, and if this is not it is not at the threshold level for the precipitation, they will not precipitate. So they will be hanging in the atmosphere again. So this will lead to the increase in the cloud lifetime. At the same time, they will also lead to the reflection of the aerosol, the solar radiation that is coming. So this will lead to increase in the cloud albedo. So increasing the cloud albedo is actually good because it will reflect more of the radiation, so it will cool. But if you know, increasing the cloud lifetime will actually reduce the precipitation. So this is not good for us at all. So this is one of the things that we must discuss about these things. Now I talk about, since this topic is actually on the northern Indo-Gangetic plain also, and so if you see this in the this slide, you see very yellowish and brownish patches there, and it's all extending all the way to the Bay of Bengal, and you can see that very high concentration. These colors indicate that there are very high aerosol loadings are there in the atmosphere already. So Indo-Gangetic plain, this is actually, we call it Indo-Gangetic plain, the entire region, and Indo-Gangetic plain is very high, has very high aerosol loading, and it is not only in a particular year or month, it's present throughout the year. Yes, please.
Your slide is not moving probably.
Oh, is it? Okay.
Yes.
And now, is it moving now?
No, sir.
Okay, so I think, let me share again
Slide
then.
number 6 is being displayed now, sir.
Sorry,
Slide,
sir?
slide number 6 is being displayed right now.
So is major sources of aerosols or carbonaceous aerosols? I'm at the slide number 8, sir.
No, no.
No, it is
It is a 6.
We are seeing
Still at 6.
still at 6.
Okay,
Yeah.
okay. Just give me a second, sir. Now, can you see this one?
No,
No, sir.
I think you will have to reload it.
So you can reload it, sir.
Okay, okay. So just, I'm sorry, actually. So thank you for the clarification. So I will just stop and share again. Okay, just give me a second, please.
Please.
Entire screen I have to share, then share. Sir, can you see now?
No, no.
No, sir. It's still the very same slide is being displayed now.
What's happening, Kunal? Can you tell me?
Leave the meeting and then rejoin. Now you can say.
Or I can then leave the meeting and rejoin if you.
Okay, okay.
It's
Okay,
okay.
that's
Okay, so just give me a second, sir. I'm sorry. These things happen in the online meetings. So just give me a second, sir. I'm just leaving and okay.
Take your time, sir.
Okay, thank you, sir. Hello, sir. Can you hear me?
You are audible, sir.
Okay, okay. Just a second, sir. Sir, I'm sharing the entire screen now. So I was at the slide number 8.
8.
So can you see the slides, sir, now?
Wait,
Yeah,
now,
it's
wait.
visible,
Yeah,
sir.
it is now visible.
Okay, okay. Thank you so much, sir. I'm really sorry for this glitch actually. So
It's okay, perfectly all right.
okay,
It happens.
okay. So if you, I was talking about that endogangetic plane has a very high aerosol loadings, and it has been verified with the aerosol optical depth, PM concentration, and then black carbon concentration as well actually. Not only that, there is a large heterogeneity in the chemical, optical, and radiative properties of the aerosols in the gangetic plane. Seasonal changes in the sources and chemical composition can influence lots of other processes like mixing state, optical properties, and radiative processing of the aerosols. So if I just put few things here, that India's multifaceted environmental problem, and I am focusing mostly here on air pollution. So what are the main issues? Like, we have seasonally varying emission sources and strength. So we have different seasons, and the emission we in different season we have different kind of emissions, and then their strength can be sometimes very small, sometimes can be very big actually. And then not only that, we have huge amount of unaccounted small to large scale biomass burning emissions, and there is a lack of good emission factors. For example, I talk about the episodic and sporadic crop residue burning in November and April, typically that take place. You have cooking, heating, dry leaves, and garbage burning. They contribute significant amount, though it has not been quantified or identified. For example, in one of the papers in Environmental Science and Technology, we found that garbage burning can contribute about 30% of PM10 in urban areas. So this is a very important study that came out, that garbage burning even needs to be controlled. So if we have to control this one, we don't need to only focus on the very small or we need not to focus only on the big players like biomass burning and industrial emissions. We also need to take care of these small scale kind of things. And I'm very happy that government is already doing lots of things in this regard, providing the gas cylinders which for the cooking purposes. So this leads to the less kind of aerosol emission in this one. Then of course we have uncontrolled and industrial and vehicular emissions. And unfortunately, I'm saying in the meeting, which I should not say probably, but often the norms are not followed actually. So industrial and vehicular emission, the kind of emission norms that are there, they are not very kind of followed. Then we have unaccounted local and transport dust at downwind sites. So any sites, for example, sites like Patna and Varanasi, where I'm sitting right now, we get lots of aerosol that is coming from the upwind locations, so this is also very important. And then the on top of this, the meteorology is another very important role that plays here. So if you just see here, I talked about this one, and I already have talked about these things. So lots of things happening. For example, if you see here, in the Himalaya, in the Gangetic Plain, the Himalaya acts as a natural barrier to the clean air in North India, and then you have a cold winds that is coming from the Himalaya sides. So there is actually mixing of the winds that is coming from the western northwest regions, and then this winds that is coming from the Himalaya, they mix together, and they actually do not allow the aerosols to further go back to the Himalayan side, or they don't push through the central India. So these aerosols are actually accumulated within the Indo-Gangetic Plain itself. So this makes it very difficult. Another very important point, especially in the winter season, the meteorology plays very important role. In the winter season, when the temperatures are lower, the boundary layers become shallower. And when the boundary layer becomes shallower, there is already an increase in the aerosol emissions. So what is going to happen? You have a limited volume for the increased aerosol number, so the concentration is going to increase. Not only that, this typically in this period, the wind speed is also very low. So this means there is not a quick dispersal of the aerosols. This is the technology that Chinese has adopted now. And actually what they are doing, whenever they are expecting very high level of pollution in the city like Beijing, they usually put lots of blowers actually in the city. But that kind of very gigantic kind of things are needed. So it is not very, of course it may be possible for India, a country like India, but it's not a kind of immediate solutions that is there. And then another big disadvantage that we have, that there is a lack of rainfall throughout the year. So we get limited rainfall in the 4 months, in the summer monsoon season, June, July, August, and September. Rest of the time, we don't get any rainfall. So rainfall actually helps in removing the aerosols from the atmosphere. But if you don't have any rain, then these will be there. So, and then I talk about the geography. So these all things actually work together, and these things all become very important during the winter time. So especially if you just see that in the winter time you have a very high level of pollution. Of course there are there and then I talk about the transported aerosols from the upwind sites to the downwind sites like Varanasi and Patna. So now what is actually, if as a scientist, if I talk about that, what could be the air quality management, a general concept. So first we need to identify that what are the components of air quality, right? So we need to do a source apportionment, means we have to identify that air quality monitoring, we have to source identification, we have to do characterization, including chemical composition and emission factors if possible, and then the quantification as well. Then if you once you know that one, then prioritize, and then you plan for the emission reduction and policy planning on this one. Not only this is one of the very important things in India, we often fail to do this one, that there is no periodic review of emission reduction policies. You know that there will be new emission that is coming in between, but then we still hold on that one, that okay, this emission has to be controlled, but we don't take care of the new emission that is there. So identification of new emission sources is very important, and I will give examples of China and Japan where I worked for some time. So this is a typical kind of things, that first you have to monitor that what is there in the air, and then you identify that which chemicals are harmful, or to be specific, what are the aerosol species or emissions that are there which needs to be put this one. This is a typical kind of things that a job of CPCB or WHO do this one. In our laboratory, what we do, these are the pollution sources. If you see in the left, they are emitting lots of aerosols in the atmosphere. We collect them. There are two ways you can do these things, monitoring of aerosols. You can do online or offline. Online methods are often very expensive, and then they provide data, but they provide data on a very high resolution scale. So that there is also a big problem, that you have a very high resolution of data, then there is a chance that you need to do lots of calculations and other things. But for quality source apportionment and other things, we don't need actually that kind of online data. Of course, for research purpose, we must do this one. So we often rely on the offline methods. And in offline methods, we use particulate matter aerosol samplers. We collect the samples, but the disadvantage is of these particulate matter samplers are that they are actually representing a particular location. So they are not very representing of the entire city. So this means that if you have a city like Patna, you have to put 5, 6, or 7 sampler or sampling locations in this one, and then you have to get an overall idea and average picture of this one. So once you collect the aerosols, you do that how much actually particulate matter mass is loading. So from here, particulate PM sampler will give you that how much time you run, what was the flow rate. So you will get actually that how much volume of air has been sampled, and then you take the difference of the initial mass and filter mass with aerosols. So you get delta M, and delta M upon V, you just do this one. So you get microgram per cubic meter. So this will tell you that whether how much PM 2.5 and PM 10 you have. Okay, and you do initial and final weighing is done by the particular weighing balance here. And then the main task start, which is very kind of sophisticated. We need lots of instrumentation, chemicals, consumables, and manpower. We need actually ECOC analyzers to just measure that what is the elemental carbon and organic carbon concentration. We need AS or ICP-MS or AES for understanding what kind of metals are there, heavy metals, and then kind of dust is there. If you want to go for a finer scale, that which source is there, then biomolecular marker has to be done. So you have to do with the GCMS, you do gas chromatography mass spectrometry, and you do TOC analyzer, total organic carbon, to quantify WSOC. So it is I am very happy to tell the audience and the colleagues or students who are listening, we have all these facilities almost in my entire in my lab itself. So we can do very good kind of analysis in this one. And then you have the chemical composition, use a receptor model, and then from that one you get that how much contribution from the source is there. So this is the typical kind of things that is needed in a methodology. And then you tell that, okay, policymakers, that okay, this is contributing this source is giving the highest one. So we need to take an immediate action on this one. We must emphasize on reducing the emission from this particular source. So once you know the source, so this is all together is a very kind of scientific and then diplomatic, you can say, in this one, and then policy making decision comes in a very strong way. I talk about this one. I give an example that by how this varying emission sources and seasonality takes place. This is the data from Kanpur that we did for 1 year, 2007 and 8. You can see winter and spring. Spring we just called for the month of March, which is neither by very high temperature of summer, although it is IMD not approved this one, we call it spring here. So here that abundance is given here in the concentration. So you have WSIS means water soluble inorganic species, TCA is total organic carbon concentration, and which is actually 1.6 into organic carbon plus elemental carbon. In the down bottom column, you can see the PM10 concentration. So now let's see that how it is happening. So if you see that in the start of the year, January 17, the concentration was about 250 microgram per cubic meter, and by the month progress, the concentration there seems to be a decline in concentration, and by February or March, the concentration reduces. And then there is actually kink in this one, or increase in the pollution. That is a different research topic. We found that there was a strong biomass burning events that take place in March itself, which lead to very high concentration. But what is this? Followed by this one in April, May, and June, the concentration of PM10 is often relatively constant, say around 150 or 170. Of course, there is a variation, but if you take an average, it is about 150 or so. So this remains not very much variations are in trend, you can see. And if you just see this trend, total carbonaceous aerosols follow the same trend. This means the PM10 concentration is dominated by TCA here and WSIS. So this is one of the very important things that we published in this year 2010, that there has been a varying emission sources which reflect in the seasonality of the aerosols. And this is compiling all the data of the Indo-Gangetic Plain and high altitudes and even over ocean region. You can see there cities like Hisar, Kanpur, Allahabad, Jadugura, they have a very high concentration of elemental carbon and organic carbon. Whereas if you see that high altitudes and ocean, they have a low concentration. This means, this very clearly tells that we have a very kind of strong emission sources that is located in the urban areas, and especially in the Gangetic Plain. One very important thing that came out of all these research that I did almost like in 15 years or so, that OC to EC ratios, I talk about OC is organic carbon and elemental carbon. So if you just take their mass ratio, the ratio is relatively constant and it is above say 6 or so. So OC to EC ratios is about 6 or so, right? I told earlier that organic carbon is scattering. So this means there is an if you have a 1 microgram cubic of elemental carbon, you have 6 microgram per cubic meter of organic carbon. So this means you have more of scattering aerosols. Okay, so this is good actually in a way, because if you just compare this ratio for the developed countries, this ratio will be somewhere around 0.5 to 2. So we have a very high OC to EC ratio. This is sometimes good for us, but what is more important, that if you take this one, this means dominance. I talk about the dominance of, so this is good for, if you talk about the climate sense, but the important is that this is mainly because you have a local emission sources at itself, and secondary organic aerosols and transported aerosols from the upwind side are not included. So in the second slide, I am talking about that WSOC to OC ratio tells about the secondary organic aerosols. So because in the urban areas are mostly dominated by the primary aerosols, whereas if you go to the urban area, high altitude size, there is an increase in the secondary aerosols. And then not only that, there is also a seasonal variability in this one. If you can see the winter, December to February and April, June, the December has concentration about PM10 concentration about 190 microgram per cubic meter, whereas in the April, June or summer, it reduces to 150 or 145. And you see that, I'm sorry, I think the picture is mixed color or mixed here. So if you see what is there, actually, if you see cyan color, and then if you see this brown, so brown is actually like, pink color. Pink color, if you see, pink color is actually kind of, that how much is actually dust. Okay, so dust contributes about 40% in the winter, but the same dust becomes about 75%. So this is very important. We have such a huge variability in the emission sources that carbonaceous aerosols, which was about 35%, it reduces to about 16% or half, and then you have dust increase significantly. And this was, you can see that that kind of dust sources that were coming at the location side. So this is also very important. Whenever we are keeping this policy planning our source apportionment, we need to have, this is why we need year-round data, and we need very good quality of the data in order to make source apportionment, so that we can provide to our policymakers. Secondary organic aerosols I talk about. I'm not going to talk much about their formation mechanisms. So basically, you have secondary inorganic aerosols and secondary organic aerosols. They are very important because otherwise, if the atmosphere is oxidizing, so this helps actually in controlling the concentration. They are very good actually. Fine mode aerosols and hygroscopics, they are very good candidate for cloud condensation nuclei. So in the areas like close to the ocean regions, you have very good kind of, if this kind of there, they can lead to the formation of clouds. And more importantly, they are very good scattering aerosols. They will have a cooling effect, but at the same time they are actually very bad for their degrading air quality. They reduce visibility, and they also lead to the fog and haze formation. And secondly, if you have a very high level of nitrate and sulfate and their gaseous species, you can have an acid rain. But this is also very important for countries like India, that despite increase in NOx and SOx concentration in India, we don't see any acid rain. And this is where that we have found that mineral dust becomes very important. If there were no mineral dust, this you frequently would have seen the acid rain. So this is very important, that because of this mineral dust, you don't get acid rain in this one. And then of course they are very important for other research purpose, like optical properties. This is a typical example of the Indo-Gangetic plain. You can see the burning events in the upwind sites, and we collected aerosol sample at Kanpur, and then we found that actually secondary inorganic and organic aerosols, they together contributed about 80% of the PM 2.5. So can you imagine that such a high concentration suddenly during the fog and haze events, they becomes very high. And we found that secondary organic and inorganic aerosols, they are the main drivers for the fog and haze formations. So this is, and then it leads to the poor air quality in the Indo-Gangetic plain. This is really very kind of issue that we need to tackle on. Okay, I just quickly go through this one, that whether we have evidence of this one. So I designed an experiment. We collected sample in the night time. You can see Kanpur N means nighttime samples, and Kanpur Day means Kanpur daytime samples. So you can see the daytime samples have a very high OC2 WSOC2 ratios. This means you have a secondary organic aerosols. So this was the this was very important research that we did. And if you just combine here all the data, unfortunately, we don't have data from Patna city. And if you see, just move in the Indo-Gangetic plain, even we have sites like Lumbini and Chitwan and Kathmandu, they also have a significant amount of this aerosol, secondary organic aerosols. So this is very important. So when we talk about the controlling the emissions, we need not to talk about the primary organic aerosol itself. We also have to talk about the secondary organic aerosol formation, their quantification, and then probably the transport in the downwind locations. This is very important slides. Why this actually good and bad aerosols are important. Okay, I talk about here. I just give an example. You know that sun is emitting radiation at about 6,000 Kelvin. And suppose these aerosol, this whole entire radiation reached on the Earth's surface, can we live here? The Earth's temperature should have been 6,000 Kelvin. If all the radiation is coming there, black body, we consider there is actually all the radiation reaches. We cannot live there. But what you see, the atmosphere, such a beautiful atmosphere we have, that radiation travels through one upon electromagnetic radiation, but the intensity of the radiation decreases as 1 upon d square, 1 upon distance square. And this radiation contains all the wavelength from high to low energy. So this means you have actually very high energy, means it can cause cancers and you can burn your skins if they are there. But what is there if these different layers are there? If these layers are there and then there are different atoms and gases and molecules, aerosols are there, they filter all the high energy radiation through various levels, at various levels by atoms, molecules, and particles that are present by either scattering or absorbing. So this is why these things are very important. Why, what oxygen level we have 21% today, it was not suddenly came in a one day. It has taken almost like 2.5 billion years. And when I say billion, means 10 to the power 9 years. So from the early, if you talk about the start, I'm not giving a lecture on this one here because of the. So if you see that when the earth was formed, the oxygen level was not there, and that's why you see that there was no living organisms in there. And then there was cyanobacteria that came into picture. They started producing oxygen actually. And then oxygen lead to, because of the photosynthesis of carbon dioxide, and then lead to, then sudden slowly and slowly the oxygen level increases, and then it increased and stabilizes about 2.5 billion years to 2. What 21% we have right now. So this has, whatever the composition or things we are seeing today, it has been accumulated in long run. Okay. So if I am saying that suppose if there was no aerosol or these processes were there, all the radiations were traveling and the earth could not have been sustainable. And the temperature actually would, because of these processes that is happening, we have a very important kind of living temperature or sustainable temperature of about 15 degrees centigrade or so. And if you talk about this one, not only that, due to the presence of aerosols and especially carbon dioxide in the atmosphere, the temperature increases to plus 15 degrees centigrade. So if you, I'm sorry, there is a typo mistakes here. The temperature, it should be minus 19, minus 15 degrees centigrade should be minus 19 here. So there is almost like 35 degrees centigrade difference in the what should have been predicted temperature and what is actually that we observe. And this observed temperature is because of the CO2. But again, I must emphasize that CO2 was good, and CO2 is good for us because we need photosynthesis need to be worked. But if we keep on increasing carbon dioxide, it will actually, because it is a greenhouse gas, so it will lead to the increase. So it's a very good saying. In Hindi we call it atika bhala na bolna, atki bhali na chup, अति भला न बरसना अति भली न धूप. तो हर एक चीज की जो अति होती है वो अच्छी नहीं होती है. So in general, I talk about the aerosols in this one, and this is what we did actually, anthropogenic and dust aerosols, and in this one, and you will be surprised that dust is actually, if I just talk about the mineral dust, it should not have any anthropogenic aerosols. But when this anthropogenic dust aerosol is emitted in the atmosphere, the anthropogenic aerosols that are produced from different activities, they are deposited on the dust surfaces. And you can see this one, like soot particles and then tar ball with lead particles in this one. So you can see the metals like copper, zinc, arsenic, cadmium, and lead. And to our surprise, we got arsenic for the very first time, that above threshold level that was there actually. So this is really very surprising to see us, that actually lots of heavy metals are emitted. So when we are inhaling, we are not inhaling air and particulate matter as such, we are also inhaling the heavy metals. So this is really not very good. Okay. But I prefer these slides, and I am very happy that we have such an ancient and culture, in environment, and what we talk about the what our ancient culture say about the environment. India was, and probably today also it is, one of the most aware country about pollution and sustainable growth. In fact, Indian philosophy strongly believed in the concept of sustainability, and we treated most of them either with the either god or goddess. Like we call Ganga Ma, we call Dharti Ma. You know, we have different kind of species. So there is actually very important Chit Jal Pavak Gagan Samira Panch Rachit Adhi Adham Sarira. ये हमारे पहले से ही हमको बताया जा चुका है कि ये 5 तत्व से हमारा शरीर बना हुआ है, और उनकी हमको कैसे रक्षा करनी है, ये हमारे लिए बताया गया है. We have been emphasized on the protection of the Dharti Mata or Mother Earth. The existence of human being in peace with these 5 elements has already been elaborated in our ancient culture. I'm not going to talk about in what you call like philosophical only, but not in a religious kind of things. I don't want to hurt somebody's sentiment in this one, but it also highlights the importance of soil for the well-being of the humans. Actually, this is very highly important. Actually, that the soil is also very important, and soil quality is very important, because if the soil quality is not there, we will not have a food grain. And this is such a kind of so surface or earth we have, that it has everything. I think if I just be very over optimistic or so, India is the only country which has almost all the resources that is needed for the living being. There are people who don't have a good soil for the food or crop production. We have such a quality of Indo-Gangetic plain, such a kind of productivity is there actually, and everything is there. Oceans are all surrounded, Himalaya is already there, everything is in a very perfect place, but only if we use these resources very perfectly. So sustainable and efficient of use of water, for example, and other natural resources are also highlighted in the Quran. This is also very important. So, and agriculture practices as discussed above must be adopted by the farmers for the good soil health. So this is also what there actually. And little bit more on this Indian culture or Bharatiya parampara. If you see, हमारे यहाँ पे 5 पंचवटी वाटिका का कॉन्सेप्ट हुआ करता था, कि जब सेंटर में किसी गांव के चारों तरफ अगर आप देखते, तो कहा जाता था कि उत्तर की दिशा में आप बेल का पेड़ लगाइए, दक्षिण की दिशा में आंवला, और पूरब और पश्चिम की दिशा में बरगद लगाना चाहिए, और पूरब की दिशा में पीपल लगाना चाहिए। आप सोचिए कितना फिलॉसफी हमारी डीप रही है। और अग्निकोण पे आपको अशोक का जिक्र किया गया है। कितनी ये बिफोर वी रियलाइज दिस इन्वायरमेंटल पोल्यूशन, our ancient people they were much aware of this one। क्योंकि होता क्या है, जब वेस्टर्लीज आती हैं, वेस्टर्ली विंड्स आती हैं, तो दीज जो बरगद के पेड़ हैं, ये बड़े हाइट के होते हैं। ज्यादा हाइट होने की वजह से दीज एक्चुअली एरोसोल्स, जो पोल्यूटेंट्स होते हैं, डस्ट पार्टिकल्स आते हैं, जो गांव में या हमारे वहां पर पहुंचते, ये वहां पर ब्लॉक कर दिए जाते थे। पीपल का पेड़ हमारे ऑफकोर्स कहने की जरूरत ही नहीं है, इट प्रोवाइड्स अ ह्यूज अमाउंट ऑफ ऑक्सीजन, कितना अच्छा ऑक्सीजन का सोर्स है। आंवला इज एक्चुअली हैज न्यूट्रिशन वैल्यू एज वेल एज एवरीथिंग। एंड बेल की तो कितनी महत्व बताई गई है सब चीजों में। एंड देन अशोक आल्सो। सो इन एंशिएंट कल्चर्स वी हैव सो मेनी इंपॉर्टेंस ऑफ आवर ट्रीज एंड अदर थिंग्स। बट मुझे बड़ा सरप्राइज होता है, एंड आई ऑफन आस्क माई सेल्फ दैट where did we went wrong? We had such a very good culture. So मेरे हिसाब से I believe that we unknowingly or knowingly over exploited our natural resources to cater our needs. I must say that, okay, green revolution was one of the very important things that happens in India. It made India, food grain sufficient. Everybody has food, right? But at the same times, we started using lots of urea, which is producing now is a source of nitrogen that is there in that one. So it is contaminating our soil and then water bodies as well. So that has becoming a big problem and challenge. We probably become greedy and not only over exploited our natural resources, but also polluted them. And today, if I say each sphere of Earth's India is polluted now, I'm sorry, this is very sorry state of affairs, but whether you talk about not only air, you talk about the water, you talk about the Ganga river, you talk about the soil, everything is polluted, nothing is there actually. We have the food quality even is that is polluted with lots of because of these activities, that whatever the food and grains and fruits we eat, they are also polluted. So now we only understand or probably begin to understand that resources are limited and we must use them judicially. So such concepts are sustainable development are very important. So can India stop? There is again a very big question. India is actually developing country, right? And still not developed country. So can India stop its growth and reduce the standard of living for the people? I think it is also not possible, right? People need good life to stay. They need good lifestyle, right? And we need lots of things that are needed for the growth. Actually, India's growth is very important for the world, and not only India, for the world as well. But it is important that we cannot stop the growth, but we cannot certainly pressurize our ecosystems. There has to be a balance that how much output we have to take out and how much we have to put. For example, we all work in some sectors where we get salary, right? When you get a salary, it is say credited on 30 or 31st of the month. So if you don't plan your salary, that how you are going to use your salary, by the end of the day or by the end of the week, within a week or 10 days, you may become actually you don't have any money. So you have to borrow from somebody. But if you have a strongly planned that, okay, this much I will be spending on this and this things, this one. So if you similarly, if you are our ecosystem is there, okay, I need this one, but actually I will not pressurize my ecosystem. I will not the harm system. I need actually trees are very important. For example, we need actually घर बनाना है, table बनाना है, सब बनाने के लिए चाहिए. But when we cut a tree, it is our responsibility to plant a tree as well. In fact, in my opinion, nobody should be allowed to cut a tree until and unless the person grows the tree in that number of equal number. So we need food, we need energy to cater huge population. This is a big problem for India. And if we have to control our pollution, we also have to control population. There is no doubt about it. So population is already there. We can't afford too much population. If it is there, it is not good for us. But at the same time, not at the cost of the human lives and damaging our environment. हमको सब कुछ करना है, लेकिन अपने इसको डैमेज करने से बचाना है. So we need a sustainable solution. So as I talked in the initially, I will give just two examples, one of Japan and other of China. This is the work that they started in 2005, 2003 or 2002, the black carbon concentration, which is, I must emphasize here that the Tokyo is actually like a developed country. So they don't have that kind of sources of aerosols that we have, like they don't have dust actually, right? They don't have other they do have sea salt aerosols and others. Anthropogenic ionic species are not there much, but this is actually, they are mostly dominated by vehicular emission. So countries like Japan, which knows that the most of the emission is coming from the vehicular emission and industrial emission, they actually pinpointed that, okay, this industry is polluting more, and they very strictly manage that in the industry. Okay, you are polluting and you have to either shut down your industry or you have to comply with the norms, whatever is there. So they did it very rigorously, and I was part of this work. And I will tell you that in countries like India, if you go to RTO or any Nigam office or anywhere to get some data, you will not get. And you will be surprised that when we visited their offices, they were so happy to give the data that it was actually like a kind of experience for me. I don't experience as a scientist here that if I need the data, for example, emission inventory data, or how much actually coal is used, how much actually vehicular emission, if I have to control, how much fuel is used, actually there is no quantification and we don't get actually the data. We have proper agencies that do everything, rules are there, but we need to, I will discuss those things and within a decade or so, they reduced the concentration almost like 80%. So what they did actually, I will see this one, excuse me, sorry. And this is the right side is the example of China. So China actually has, now we have to somehow adopt that kind of, methodology like China adopted. It produces a lot of things, becomes, economically strong. And then now they are putting lots of, strategies to cut down the emission. But countries like India has again a problem. We have been able to develop, make ourselves as a developed nation, and at the same time not we have been able to control our emissions, our pollution. So we have both the things. So now our job is actually very important, and it is very important for us. So what they did actually, so they made very good quality source characterization and apportionment studies. They monitored the pollutants to the greater accuracy and established major emission sources. This is very important. As a scientist, this has to be done, and this was done. But from the policymaker and then other side, they implemented stringent regulations on emission. They said that, okay, all the vehicles, if they are older than 10 years, they must be removed. All the vehicles, heavy vehicles especially, they were removed. And they followed up and regulated emission, industrial emissions. So they did it very well. they managed agricultural waste. For example, in Japan, which produces a good amount of rice there, they used their actually technologically into they converted into some useful products. They shifted their energy sector to more of renewable energy, and I'm very happy that Indian government is doing this one. But I think we need to speed up. They also made a very well-planned awareness programs to the public who made this understood and problem took it seriously. This is what is actually done. So we need, so what we know emission sources and quantification slightly better, but we need to prioritize on the managing emission industries. Don't just implement and stringent regulations on emissions, but follow them on a regulated basis. This is very important. And we need to shift, of course, on this one. So I have got the message that I need to wrap up this one. So I'm just going to this one again, just a last slide, last couple of slides, that management of agriculture waste or parali burning. You know, as a scientist or as a policymakers, I cannot just blame the farmers, right? Until and unless we give them a good solution. But there are technologies who does exist actually practically. For example, they can decomposers have been prepared by then biochar production and then conversion into the useful products. But the problem with here that these processes are later very slow. They have a very low calorific value, so they are not good for energy use. The product, if you prepare table or chair, they are not very stable, so people are not going to buy this one. And then the transition between wheat and rice sowing is only say 15 to 20 days. So the farmers has to, they have no option in this one. Okay, so this is what is actually. So there is actually, we talk about, as a chemist, I talk about the green chemistry to solve our problems. But can a chemistry solve our all environmental problems? No, the answer is very big no. There is a need for multidisciplinary and interdisciplinary team. Most of the environmental problem, because most of the environmental problems do not have a unique solution. For example, biological treatments do not discard with the help of physicochemical treatments. So we need chemists, engineer, agriculture scientists, geologists, policymakers, environmentalists, everybody to tackle the solution. We need to emphasize on the we science, not the me science. Means whatever the science I am doing, and I am very happy that Bihar Pollution Control Board and then bodies like that, they are actually popularizing this science, my science actually. So what the science I do, me science, you are actually popularizing this one. So there has to be more on the focus on the we science, okay? Again, don't think on the disposal itself. We need to think on the recovery. So just to continue, Mother Earth is crying. What do we need to give to our children, our grandchildren? I ask this question to myself. Do we need to give? I'm just take 2 minutes, sir. I'm just in the finishing this one. So do we need to give them money, house, or education? I think in my opinion, we need to give them a better environment to live, right? So to conclude, as I talked about that Earth provide enough uh, to satisfy every man's greed, but not any man's every man's need, but not any man's greed. This is actually very good in the accordance with this one, and then fulfill this also very important. And in one of the lectures I attended, and I quote here Professor Choi. He is actually from the he mentioned that cutting our energy uses without affecting our lives. So this is very important. We need energy, but we should be focusing on cutting the energy without actually emphasizing our daily life. For example, if we actually are, if the lights are not needed in the daytime, we should switch off these things. So these statements are very true and logical. And we have already starved for the oxygen during COVID time. But do I ask myself, but do we learn from this? I think we have not learned at all. And consequences, but if we don't learn, consequences would be disastrous. Note that it is we who need earth and its resources, not the other way. So let's keep our environment clean, green, and healthy place to live. This is a high time, I must say, that act now and never before it becomes too late. And I am very happy that agencies are taking needs of this one. This is the kind of air quality management plan I discussed with you. So I stop here, and thank you everybody for your patience listening. So thank you. I'm done with this one, and I would be happy to take any question. But before this one, I must thank BSPCB team for inviting me for this lecture, Department of Science and Technology, SERB of Government of India, ISRO, and then Ministry of Foreign Affairs, Japan, Alexander Van Humboldt Foundation, Germany, and NASA for some funding supports, which we carry actually, and we do some collaborative research on these topics. So thank you very much, and I hope I was able to convey the message actually. Thank you so much, sir. Thank you.
Switch on your camera.
Thank you, Dr. Ram, for this wonderful lecture.
Thank you so much, sir. Thank you. I hope I was able to convey the message, and then yeah.
So let us give again a big hand for Dr. Ram.
Thank you, sir.
So now the floor is open for discussion, and I would request our online participants have any query or any clarifications from Dr. Ram. They can raise their hands online. So our chairman,
our chairman sir has also joined now. So welcome, sir. We were looking for you, sir.
Hello, sir. Good afternoon, sir.
Your mic is muted.
I'm sorry, I was delayed because I was busy in another meeting. And still, I was able to see a couple of slides presented. So thank you very much for that. A few comments to sum it up, whatever I have heard. The last slide that you said, Mahatma Gandhi's quote.
that is a very favorite.
My favorite quote with a chain.
Oh, sir.
महात्मा गांधी ने कहा था कि मदर अर्थ हैज एनफ फॉर आवर नीड बट नॉट नीड. आजकल मैंने उसको मॉडिफाई कर दिया है. मदर अर्थ के पास अब हमारे नीड के लिए भी नहीं है सफिशिएंट, गिड के लिए
बिल्कुल सही बोल रहे हैं सर. यस,
महात्मा गांधी ने जब कहा था तो ये ठीक था कि नीड के लिए काफी है, ग्रिड के लिए काफी नहीं है. लेकिन आज बदल गया है परिस्थिति, नीड ग्रिड दोनों खत्म हो गया है. तो ये हम लोग को सोचना होगा कि कैसे इसको रोकें. दूसरा पॉइंट सोर्स के बारे में कह रहा था, आपने कुछ कमेंट किया था कि किस सोर्स से एमिशन होता है एयर पोल्यूटेंट्स का, वो थॉरो स्टडी करना चाहिए. बिहार में हम लोगों ने जो 3 नॉन अटेनमेंट सिटीज है उसमें हम लोगों ने एमिशन इन्वेंट्री स्टडी किया है. और जो स्टडी किया है उससे पता चला है कि जो मेजर सेक्टर है जहाँ से आता है एयर पोल्यूटेंट्स, वो ट्रांसपोर्ट है, डोमेस्टिक है, डस्ट है, वेस्ट बर्निंग है, और एक सबसे इम्पोर्टेंट है आउटसाइड सिटी लास्ट. और लास्ट सबसे ऊपर है. दैट इज द बिगेस्ट चैलेंज. है कि जो 3 नॉन अटेनमेंट सिटी है बिहार का, पटना, गया, मुजफ्फरपुर, उसमें जो आउटसाइड सिटी से जो स्रोत आ रहा है पोल्यूटेंट्स का, उसका रेंज है 29% to 44%. मुजफ्फरपुर में इसका है 44% और 29 है, कम है थोड़ा. इसका कारण है जो डिस्ट्रीब्यूशन है लोगों का पटना के आसपास है, मुजफ्फरपुर के आसपास. और प्रॉब्लम ये है कि हम लोग सारा एनर्जी फोकस करते हैं जो शहर में प्रदूषण हो रहा है उसको कम करने का. गांव के बारे में सोचते हैं कि गांव में स्वच्छ हवा है, गांव में प्रदूषण का कोई प्रॉब्लम ही नहीं है. तो अगर प्रॉब्लम का कुछ नहीं है गांव में स्वच्छ हवा का, वहां पर बिल्कुल बहुतायत में है. ये 44% कहाँ से आ रहा है? और जब 44% को हम एड्रेस नहीं करेंगे तब तक एयर पोल्यूशन का मामला को हम लोग एड्रेस नहीं कर पाएंगे. अभी टेली का भी मीटिंग चल रहा था, उसमें भी मैंने इस प्रश्न को उठाया था कि प्लानिंग है वो फॉल्टी है, ऐसा हम लोग को नहीं करना चाहिए और हम लोग को गांव पर भी ध्यान देना होगा. और इस दिशा में हम लोग काम भी शुरू करने जा रहे हैं IIT कानपुर के साथ, जिसमें थोड़ा मॉनिटरिंग हम लोग रूरल एरिया में भी करना चाहते हैं, जो हाल में शुरू होगा. तो अंदाजा लगेगा कि स्थिति क्या है. एक्चुअली गांव को हम लोग गांव के परिप्रेक्ष्य में अभी भी देख रहे हैं. हम बहुत दिनों से गांव को देख रहे हैं और रिसर्च के सिलसिले में गांव में काफी घूमते हैं. अगर हम सन 2000 के गांव को 2023 के गांव से कंपेयर करते हैं तो परिस्थिति काफी बदल चुका है. अधिकतर लोगों के दिमाग में सन 2000 वाला ही गांव है दिमाग में, माइंडसेट में, और उसी को सोचकर प्लानिंग करते हैं. ये नहीं जानते हैं कि 2023 का गांव अब वो गांव नहीं रह गया.
नहीं रहा. राइट सर.
और वहाँ भी जो जीवन शैली है उसमें बहुत बदलाव आ चुका है. पहले पूरे गांव में एक आध गाड़ी हुआ करता था, अब ऑलमोस्ट हर गांव में 30-40 गांव तो गाड़ी तो मिल ही जाता है. AC फ्रिज भी होता ही है. 2 व्हीलर तो बहुत हो गया है. लाइफस्टाइल में चेंज आ गया है। तो ये एड्रेस करने के लिए, समस्या को एड्रेस करने के लिए हम लोग को देखना होगा पूरे एयरसेट को, इसमें गांव शहर सभी शामिल है, तभी ये कंट्रोल हो सकता है। और तीसरा लास्ट पॉइंट मैं ऐड करना चाहूंगा, आपने कहा कि कैन वी स्टॉप द ग्रोथ ऑफ द सिटी और कैन वी स्टॉप द बेटरमेंट ऑफ लाइफस्टाइल, और आपने कहा नो वी कैन नॉट। आई एग्री विथ यू कि ये सब तो बढ़ेगा ही, जीवन शैली को जो चेंज हो रहा है उसको रोकना बहुत मुश्किल है। लेकिन एक चीज बहुत जरूरी है आज के परिप्रेक्ष्य में, कि अर्थ पर जो बर्डन बढ़ गया, जो शुरू में कोट किया मैंने, उसका एक प्रमुख कारण है आबादी। 8 बिलियन हम लोग क्रॉस कर चुके हैं,
राइट सर।
और 8 बिलियन हम लोग का कैरिंग कैपेसिटी से ज्यादा है। तो कम से कम इसको तो रोक सकते हैं। ठीक है, हम ग्रोथ को नहीं रोकेंगे, शहरीकरण को नहीं रोकेंगे, या लाइफस्टाइल का चेंज को नहीं रोक सकते, लेकिन पॉपुलेशन का ग्रोथ को तो हम लोग रोक सकते हैं।
राइट सर, राइट।
इंडिया आजाद हुआ था तो 36 करोड़ थे, आज 140 करोड़ हैं। तो अगर इस शताब्दी के अंत में हम लोग 220 करोड़ हो जाएंगे, तो क्या होगा इसका अनुमान लगाया जा सकता है। तब तो ग्रीड नीड ये भी फेल कर जाएगा, सर्वाइवल स्रोत नहीं रह जाएगा। So thank you very much. Thanks a lot for your lecture. I could not listen all of it, but whatever I have heard, on that basis I have made a few comments. और एक वे फॉरवर्ड भी कहा हुआ है, अनाउंसमेंट है लेक्चर का, वो कर ही दूं, उसके बाद मैं हैंड ओवर करूंगा अपने सूत्रधार जी को आगे का कार्य। यह है अनाउंसमेंट फॉर 9th लेक्चर ऑन March 3। इस सीरीज में 9वां लेक्चर है 3 मार्च को 3 बजे 3 PM बाय डॉक्टर गोपाल शर्मा, जो कि साइंटिस्ट ई हैं और ऑफिसर इंचार्ज हैं जूलॉजिकल सर्वे ऑफ इंडिया रीजनल ऑफिस पटना। और उनका जो एड्रेस होगा, उसका थीम है पार्टनरशिप फॉर वाइल्ड लाइफ कंजर्वेशन, माइक्रोफाउना एज वाइल्ड लाइफ। तो ये एक अनाउंसमेंट है बाकी श्रोताओं के लिए और हमारे बोर्ड के सारे सदस्यों के लिए, आपके लिए भी। आप सभी आमंत्रित हैं। थैंक यू वेरी मच। ओवर टू सूत्रधार।
Thank you, sir. Thank you for your nice and detailed remarks. और आप तो हमेशा से कहते आ रहे हैं कि जो हमारी कैरिंग कैपेसिटी है अर्थ का, वो पूरा हो चुका है। We need 1.4 अर्थ for that to even fulfill our need. तो of course नीड के लिए भी शायद हमारी मदर अर्थ के पास कुछ नहीं बचा है। सो इट इज द हाई टाइम टू बी वेरी वेरी केयरफुल, आई शुड से। और इसमें हम सबों का प्रयास, हर एक सिटीजन का प्रयास जो है वो अपेक्षित है, नो डाउट अबाउट इट। और इसी के साथ में और भी कोई पार्टिसिपेंट्स हैं तो आप लोग में से कोई स्टूडेंट्स तो हाँ, यस। सो our colleagues Jaiswal ji will like to have some
धन्यवाद नवीन जी और कृपा साहब। फिर ही आपने जो आज इस लेक्चर सीरीज में आज जो प्रेजेंटेशन दिया और व्याख्यान दिया, वो निश्चित रूप से आपका व्याख्यान जो हमारी आवश्यकताओं के अनुकूल थी। एक्चुअली हमारा जो आपका इशू, अपने एयर इशूज कैरेक्टराइजेशन मैनेजमेंट के बारे में बात किया, निश्चित रूप से हम अपने रेगुलेटरी फ्रेमवर्क में जो व्यवस्था कर रहे हैं अपने उसको नियंत्रित करने के लिए, वो निश्चित रूप से कर रहे हैं अपने व्यवस्था के अंतर्गत। लेकिन आपने जो आज जो लेक्चर में जो आवश्यकता है, हमारे जो विज्ञान और हमारे भारतीय अतीत को, दर्शन को, इथिक्स को और सारे स्पिरिचुअल थिंग्स को क्लब करके जो सारी बात बताई, उससे निश्चित रूप से हमें उन दिनों पर ध्यान देने की जरूरत है। जैसे पंचवाटिका, जैसे आपने पंचवाटिका के बारे में बात किया, क्षितिजल गागर गगन पावल शीरा ईशम बारे तत्व को व्याख्यान किया। तो हमारी जो प्रदूषण की जो स्थिति है और हमारे भौगोलिक परिवेश में जो हमारी विस्तृत स्थितियां हैं, उसको निश्चित रूप से कम करने के लिए, या विशेष करके वायु प्रदूषण या नॉट ओनली वायु प्रदूषण को नियंत्रित करने के लिए निश्चित रूप से हमें जरूरत है प्रकृति के साथ भावनात्मक संबंध बनाने का। जब तक हम प्रकृति के साथ भावनात्मक संबंध नहीं बनाएंगे, हम अपने उस चीज को मतलब कि गुण को प्राप्त नहीं कर सकते हैं। जैसे आपने कहा कि हम पीपल की पूजा करते हैं, बरगद की पूजा करते हैं, पंचवाटिका हमें व्यवस्था बनाया है सभी दिशाओं में, ताकि उसका साइंटिफिक बताया अपने कि इस दिशा से जाए कि हवा जाए कि रोके कि बरगद का पेड़ दूसरी दिशाओं में क्या न्यूट्रिएंट्स वैल्यू है। तो ये सब चीज पर ध्यान देने की आवश्यकता है। हमें आज भी हमारा इथिक्स जो है, कल्चर जो शुरू से हमारे पूर्वजों ने बताया, वो विज्ञान सम्मत था। तो विज्ञान सम्मत और आध्यात्मिक सम्मत के पृष्ठभूमि में अगर हम आगे बढ़े तो अपने यहाँ परिवेश को और प्रदूषण नियंत्रण दिशा में निश्चित रूप से बहुत ही कारगर कदम उठा सकते हैं। तो ये सारी बातें निश्चित रूप से आज के न्यू जनरेशन को जानकारी होनी चाहिए और आवश्यकता उस दिशा में पहल करने की। हम अपने रेगुलेटरी नियम के तहत जितने भी कार्रवाई है वैज्ञानिक सम्मति में पोल्यूशन कंट्रोल मेजर्स के लिए आप टेक्नोलॉजी इंटरवेंशन के बारे में बात करते हैं, सारी कीजिए, लेकिन सबसे चीज है कि हम हर व्यक्ति को प्रकृति के साथ उन भावनात्मक संबंध बनाकर रखेंगे। गंगा को कहते हैं गंगा नदी है, तो गंगा नदी है मतलब गंगा हमारी माँ के रूप में दर्जा करते हैं, तो मतलब माँ को जो दर्जा दिया चाहिए, जो ऑनर करना चाहिए, वही करना चाहिए हम। तो सिर्फ नॉट लिमिटेड टू गंगा, हम अगर नदी गंगा के और इसके सहायक सभी नदियों को अगर हम उसकी उसी प्राकृतिक भावना के साथ जोड़ेंगे तो हम उसका आदर करेंगे, तो निश्चित रूप से उसमें कोई प्रदूषक को हम लोग निश्चित नहीं कर पाएंगे। उसी प्रकार से जो हमारे इकोलॉजी का और जो पेड़ पौधे हैं सब कुछ का पूजा करते हैं, तो उसी पूजा के करने के भाव से भी अगर करते रहे कि भाई हमको इसी रूप में बचाना है, उसका संवर्धन करना है, तो निश्चित रूप से अपनी हम समस्याओं का निदान कर पाएंगे और अपने परिवेश को स्वच्छ रख पाएंगे और हम अपने प्रकृति के आड़ में बैठ के प्रकृति के भावना से बना करके हम अपने लक्ष्य को प्राप्त कर पाएंगे। धन्यवाद।
थैंक यू सो मच सर, थैंक यू।
थैंक यू जायसवाल जी। आपका दर्शन एकदम सही है और बल्कि मुझे तो ये लगता है कि शायद हमारे पूर्वजों ने हमारे जो प्राकृतिक संसाधन है उसके गुणों को, उसके महत्व को समझ करके ही उसे हमारे रिलीजन और हमारे फिलॉसफी से जोड़ा, सो दैट कि हम उससे भावनात्मक रूप से जुड़ सके और उसे संरक्षित करें। अगर सीधे लाभ के लिए नहीं तो एक संस्कृति और धर्म के नाम पर, तो निश्चित रूप से वो जो समन्वय है और उसको जो जोड़ा गया उसका मूल उद्देश्य मेरे हिसाब से यही रहा होगा।
हमारा जो लेक्चर सीरीज का भी काम ही हुई
और हम लोग इसी प्रयास में लगे हुए हैं कि किस तरह से अधिक लोगों को अपने इस मुहिम में जोड़े, स्टूडेंट्स, रिसर्चर्स, आम जनता और सबों को लेकर के, चूंकि पर्यावरण संरक्षण का जो अभियान है, जो लक्ष्य है, वो किसी भी एक संस्था, एक ऑर्गेनाइजेशन, एक सरकार या किसी गैर सरकारी संस्था के द्वारा नहीं हो सकता है। इसमें हर एक आम नागरिक का योगदान जब तक नहीं होगा हम लक्ष्य को प्राप्त नहीं कर सकते हैं। तो ये लेक्चर सीरीज का भी हमारी भावना, हमारा उद्देश्य वही है और जिसमें आज डॉक्टर राम का महत्वपूर्ण योगदान रहा है इस कड़ी में। हम सभी आपके लिए आभारी हैं और सर थैंक्स।
If there is no any other question from the virtual participants or from those who are present physically here.
Sir, vote of thanks के लिए सर मैं
Okay, thank you. So, respected chairman sir, our esteemed today's speaker Dr. Kripa Ram sir, Institute of Environment and Sustainable Development, Banaras Hindu University, Varanasi. Dear participants, my dear colleagues here who have joined us physically here, I thank all of you for sparing your time and to listen to Dr. Ram, who is one of the renowned scientists in the field of environmental pollution pollution monitoring and management. Sir has got wide experience in, especially with respect to the aerosols pertaining to the its interaction with the meteorological parameters in the Indo-Gangetic plains. And we are in touch with Dr. Ram for quite some time. And sir, we are really grateful to have you today. Your lecture was really informative, and this will be very useful for all the participants who have listened your lecture. And this will be a good guidance for all those young researchers. I could see some of the researchers who have joined us physically here from this State Pollution Control Board also. So with these words, I am looking forward to meet you once again here physically at your convenience, sir. Thank you so much for accepting our invitation. So on behalf of State Pollution Control Board and our chairman, sir, and all my colleagues, I thank you once again, sir. Thank you all of you. Good day.
Thank you so much, sir. Thank you.
Just a request, can all of you, those who have joined virtually, if you could switch on your video, we can have a group photograph.
Please be available in our website.
And for the information of all the participants, the presentation will be available in our website. And this has been, I think you must be knowing that this has been live streamed in the YouTube also. You can listen and you can refer this to your friends who are interested in this topic to listen later time also. Mr. Kumar 1.181, Mr. Chachai. Anybody else? Okay. So with this, we come to the conclusion of this program. Thank you once again. Good day to all of you.
Thank you.
Thank you so much, sir. Thank you.